Hello everyone, my name is Saloni and today we'll discuss a question that will be helpful to you for all physics competitive exams. And so our question says that there is a 300-gram ball and 600-gram ball, and these are connected by a 40 centimeter long massless rigid rod. And the structure rotates about its center of mass at 100 rotations per minute. What is its rotation kinetic energy? Okay, so first of all, we'll draw two balls. One ball is of 300 grams and one is of 600 gram. Okay, and omega is 100 rpm. So when you convert it into radians per second, what you do, you multiply it by 2 pi by 60, because in one rotation there are 2 pi radians, and in per minute, so it's per minute, so in 1 minute we have 60 seconds. Okay, now what we'll do, we'll take this as our reference point and we'll find our xcm. Okay, so let this distance is xcm. Okay, so how to calculate xcm? It's m1 x1 plus m2 x2 divided by m1 plus m2. Okay, so we put the values xcm. We'll put everything in grams and centimeters, because of course in numerator and denominator both are in grams, so that unit get cancel out, and if we take x, like in this x1 and x2 in centimeters, so our resultant xcm will also be in centimeters. Okay, so 300 into the position, the center of, this is the center of mass of the first ball, which we have taken as our reference point. Okay, so this is 0 only. X1 is 0. And for 600, this x2 is the distance. And what it's given in our question is given 40 centimeters. So we'll put it as 40 centimeters divided by 300 plus 600. So when you calculate this thing, we have, like, you solve this, you get 26.67 centimeters. So from first ball, like 300 grams, we have distance of our center of mass is 26.67. Now we need to calculate the rotation kinetic energy. Okay, because in our question it was given that the system rotates about its center of mass, so that is why it is important to calculate center of mass first. Why? Because now as we have calculated our center of mass, we know the distance from the first ball also. Okay, and the second ball also, we know the distance from of both the balls from center of mass, and now we can just calculate our moment of inertia. So for moment of inertia, I is equal to m1 r1 square plus m2 r2 square. And after we calculate moment of inertia, for kinetic energy, rotation kinetic energy, will do half I omega square, because omega for both the balls are same only. Okay, so m1 is equal to, now we'll write it in our SI units, because we want this moment of inertia in SI units. So for 300 gram, m1 is 0.3 kg, r1 is xcm, which we got as this. So this is 0.2667 meter. So this is 0.2667 whole square plus m2. Okay, what is m2? M2 is 600, which is 0.6 into the distance this. So what is the distance? This distance is 40, which is in centimeter, minus 26.67. Okay, so this thing comes in centimeters, and this thing comes as 13.33 centimeters, and when you convert it into meters, you have 0.1333. Okay, square. So our final moment of inertia comes as, when you solve this complete equation, 0.3 into 0.2667 whole square plus 0.6 into 0.1333 whole square. So this comes as 0.032 kg meter square. So this is our moment of inertia. Now for calculating the rotational kinetic energy, we have k rotational is equal to half r omega square. Okay, so half into 0.032 into omega we calculated as 100 into 2 pi by 60. Okay, so it's 100 into 2 pi by 60 whole square. And so finally, if you calculate this thing, it comes as 1.75 joule. This is how you solve these type of questions. So thank you for watching this video. If you like our content, please subscribe to our channel to learn more about physics.